graph a line using intercepts? More than one intercept? Well, I guess that would make sense, right? Because lines are always going to cross, not always, but there's only two special cases. But they're always going to cross, in general, both axes. So if I did know what the y-intercept was, let's say 0, 2, 0 on the x, 2 on the y, and I knew what the x-intercept was, let's say it's negative 3, 0, that means it's going to 1, 2, 3 cross the y-axis there. Because I know those 2 points, I can then graph that line just like so. That's graphing with intercepts. Now what we're going to do though is we're going to take the equations, the linear equations that we have, and determine what those intercepts are so that we can graph. Here we have a linear equation, and when we look at this, what form is it in? Do you remember? Good, slope-intercept form. It's in slope-intercept form, but let's find what the axis intercepts are, what the intercepts are. And you know what I'm going to do? I'm going to just make a small table here for x and y, and I'm just going to solve this using x as 0 for one of the x's and 0 for one of the y's. Let me show you. I think it's a little bit less confusing if I do it. So if we put 0 in for x, that's going to look like this. Y equals 2 times 0 minus 3. Y equals 2 times 0 is 0 minus 3. Y equals negative 3. So I'm going to put negative 3 into my table. Now, I've got the y-intercept. Let's find the x. To find the x, we're going to put 0 in for y. All right, so that gives me 0 equals 2x minus 3. Now let's add 3 to both sides because we want to isolate that. So negative 3 and positive 3 combine to 0, giving me 2x equals 3. And now I need to solve for x. Now don't get stuck here with the size of the numbers. Keep doing what we normally do. We want this to be 1x, so we're going to divide that by 2, divide that by 2, and get that x is 3 halves, or 1.5. So I'm going to put 3 halves here. And now I have the two intercepts. All right, 0, negative 3, 0, 1, 2, 3, negative 3. And 1.5, 0, or 3 halves, 0. So there's 1.5 and 0. Get my handy dandy straight edge. And then from there, I can graph that line. Success. Here's another linear equation, but this one's not in slope-intercept form. So we can convert it into slope-intercept form or if we want, but the truth is this is a different kind of form. So what we know so far is we know that this y equals mx is direct variation. We know that y equals mx plus b is slope-intercept form, right? And this, where we have a coefficient in x, a coefficient in y, and the constant on the right side of the equal sign is called standard form. Standard form. And standard form, algebraically, in a general sense, looks like this. Capital A, lowercase x, plus capital B, lowercase y, equals C. Now the only caveat to this is when we're in this form, that, and that, the A, the B, and the C have to be integers, which means they cannot be ratios, right? They cannot be rational numbers, which means they can't be fractions or decimals. They have to be integers, and this is the other twist, A has to be, whoa, that's not B, B greater than 0. And once we have that, we've got an equation that we can work with just as easily as slope-intercept form. So going back to this now, let's look at this. We have an equation that's in standard form, and we want to find our intercepts. So what we're looking for is, where does it cross the y-axis? Where does it cross the x-axis? Let's start by substituting in 0 for x. So we get 3 times 0 minus 5y equals 15. 3 times 0 is 0, which means I've got negative 5y equals 15. Divide by negative 5, and we get y equals negative 3. So there's our first point. That's our first intercept. When x is 0, y is negative 3. So that's one of these. And now we're going to do it again, but this time we're going to substitute 0 in for y. 3x minus 5, parentheses 0, equals 15. 3x, or 5, negative 5 times 0 is 0. So I get 3x equals 15. X equals 5, which means my other point is 5 comma 0. My y is 0, my x is 5. I can't stress enough, like, kind of the importance of making sure you write a statement like this at the end in order for you to keep track of what's what you've determined. It helps to be able to look at your paper and know what you did rather than keeping that stuff in your memory. Anyway, let's graph this. I got 0, negative 3, 0 on the x, negative 3 on the y, and then 5 on the x, 0 on the y. 1, 2, 3, 4, 5. Now we have our thinger. Let me get my handy dandy straight edge. Put this on here, find my corner and my corner, and we've graphed that line. Oh, nice, a word problem. Okay, the store sells juice boxes in packages of 6 and 8, 288 total juice boxes, represented by the function. Oh, a function, that's cool. All right, that's something new. Function 6x plus 8y equals 288. Now, I can't stress this enough that let your paper and your pencil or pen, whatever you're working with, do your thinking for you so that you can save your thinking for the math. All right, juice boxes and packages of 6 and 8. Okay, so X is a package of 6, Y is a package of 8. All right, just so that I remember that, use the X and Y intercepts to graph the equation. If we're not going to graph it, then interpret the X and Y. That's what we're going to focus on. All right, so let's figure out if we have 0 for X, 6 times 0 plus 8Y equals 288. 8y equals 288, y equals, 8 goes into 28 3 times for 24 with 4 remaining. 8 goes into 48 6 times, right? 8 times 6 is 48, yeah, okay. So that means we have one point that is 0, 36. That's one of our intercepts. That's our y-intercept because x is 0. Now let's figure it out the other way. Let's figure out what the x-intercept is. So if I have 0 in for y, I've got 6x plus 8 times 0 equals 288. 6x equals 288. X equals, all right, how many 6's in 28? There's 4. And how many are remaining? 4. That works, 48. So then I've got the point 48, 0. Great job, I got the intercept. All right, so we know what the intercepts are, good. But what do these mean? What do these mean? Let's look back at the problem here. The store sells juice in packages of 6 boxes and 8 boxes, 288 juice boxes. All right, interpret what the graph means. All right, so what the graph is telling us is, and I'm going to look back to what I made previous so that it keep things on track for me. So if X is a package of 6, if I sell no packages of 6, for me to make $288, no, for me to have 288 juice boxes, I need 36 8-packs. So when there are 0 6-packs, there are 36 8-packs. That's an interpretation of what we just did. The same thing has happened here. When there are 48, no, let's start with the 0. 0 8-packs, there are 48 6-packs. Just something simple to use, not necessarily the thing that's going to be like the make or break for your job, but the way that the thinking works is how we're going here. Like, how do we think about things in terms of real world situations? This is exactly the pattern of thinking that you would use, not necessarily the algorithm, but this is how you would think about something in terms of splitting up. Let's say you have store space for 288 bottles or packages. If you only have that much store space, then you've got to balance the number of 8-packs and 6-packs to make sure that they all fit. Vocab. All right, let's look at the vocab. We've got standard form, AX plus big BY equals C. That is standard form. It's a great form for using intercepts for graphing things. So we have the y-intercept and the x-intercept, and I know I said that backwards, where the line crosses the x-axis and where the line crosses the, I hope you're going by my voice and not trying to read my writing, y-axis. Good. All right, so we're up to 3 different forms now. We've got direct variation, slope-intercept form, and we've included standard form now. We can graph equations now with a slope and an intercept. We can graph equations with 2 intercepts. We're doing really well. All right, guys. Good luck.